Hi, today we're going to continue our lesson on inequalities, and today we're going to talk about a compound inequality. I'm not going to read through everything because I know you guys can, but make sure that you read through everything. And just like the word compound, it means more than one inequality, okay? More than one inequality symbol. So basically, you're merging two inequalities into one, okay? So we're going to talk about three different types of compound inequality. The first one that we're going to talk about is a three-part inequality, which in this example, it's already solved. It's there, it's defined. So basically, the solution to this inequality would be all values that are -2 or greater, but less than or equal to 3. Okay, so any values between -2 and 3 would be a solution and can be included in the interval. Now we're going to move on to show how we would represent that inequality on a number line. So all you would need to do is to draw a number line, identify your 0, and then identify the left bound and the right bound. So -2 would be a closed dot. It's less than or equal to. 3, +3 is also a closed dot because it's less than or equal to. And then all you would do is shade to show that the solution is all the values between those two. You shade it like I did in brown, okay? Now we're going to move on to interval notation, and we talked about that in the previous video. So it's left bound, far left bound would be -2, and because that circle is closed, it would be brackets. Far right bound, how far right does it go? It goes to 3, and that's also brackets because it's closed. Set notation is something that you will see in ALEKS, and you will have to input your answers using set notation. Basically, all you do is you start with some squigglies. X is a value such that, and that vertical line means such that. And then here is where you input the inequality. So it would be -2 less than or equal to x less than or equal to 3. And then you close it with the squigglies. And then you would read that as a set of all values of x such that x is equal to or greater than -2 and less than or equal to 3. Now we're going to move on to an example that is not solved. So here we have our example that is not solved. We have to move this over so that way so that the variable could be isolated. So just like we would do before, we'd do -4, but you have to do -4 on both sides. When you do that, that zeroes out. This becomes -9. You bring down the less than symbol, you bring down the variable, bring down the less than symbol, and that becomes a -3. So that's how you would solve the inequality. And now you have your inequality, and that's what we would represent on the number line to show all the solutions. Start with 0. My left bound is -9. Then my right bound is -3. That -9 is open because it's less than, not equal to, and same thing for the 3. And then all you would do is shade in here to show that it includes all the values greater than -9 but less than -3. Okay, moving on to interval notation. How far left does that graph go? It goes to -9. Now I use the parenthesis because it's open. It's not equal to, it's just less than. And the same thing for the 3. We'll use parentheses. Brackets indicate that it's closed, it's equal to. And then set notation, you start the squiggly, x, values of x such that -9 is less than b, which is less than -3. And then you close it. And that would be it. So now we're going to move on to examples when you see the word and the word or. When you see the word and, you need to think of an intersection, okay? That intersection of A and B is denoted with an upside down U. So it looks like this. And basically here you have set values A and set of values B. You want the values that repeat for both, that are included in A and B. as to where a union, you want A or B. So basically that would be all the values of A and or I should B. So everything. Now here's an example of how I can explain this a little bit better. Here are the values for set A. Here are the values for set B. If we look for the intersection and what values do they both share? They both share a 3 and they both share a 5. So therefore the intersection and of A and B would be 3 and 5 because those are the only numbers or elements both in A and B. That's what and means, both. And then once again, that's denoted with an upside down U. And this is how you would represent the solution to show. Now we're going to move on to the union, and that's the or of A and B, and that would be all number elements in A or B or in both. So that's why here the interval notation has all of them, because or means all in both. So now we're going to move on to some examples of how you will see this and how it's going to look and how to apply it. So the first example that we're going to be working with, it has the word and, okay? When two inequalities are connected by and, that means a solution set will consist of the values that make both inequalities true. So keep that in mind. And now here to the right, I have some steps, and these are the steps that we are going to follow to find the solution and write it in interval notation. So the first step says to solve the two inequalities. So I'm going to go ahead and solve the first one. And then after I solve the first one, solve the second one. And so after we solve, we get C is greater than or equal to -2 and C is less than or equal to 4. Now we're going to move on to the second step. We're going to graph the solution sets to each inequality on its own number line. So each inequality gets its own number line. There's number line number 1, and then here's the second number line. I'm going to identify 0 for the first one, and then -2, which is right here. So the values of C have to be greater than or equal to, so then this would be a closed circle, and greater than means we're going to go to the right, and it keeps going on forever, infinite, okay? Now I'm going to do the second number line. I identify my 0, I identify my 4. C is less than, the values of C have to be less than or equal to, because it's equal to, then that circle is closed, and less than means to the left, lower numbers, okay? And that keeps going on for -infinity. So now we're going to move on to step 3. Use the two number lines to graph the solution set. A third number line, which will consist of the regions where the separate number lines intersect or overlap, okay? So this is very important because and is what they both share. So here's my third number line. I'm going to identify 0. Okay, and then I'm going to go to -2 and then to 4. This is closed, and this is closed because it's equal to. So then all you do is fill in the values that are in the middle to show that your solution could be negative, any value from -2 to +4. And now all we have to do is write that in interval notation. That would be our last step. And in interval notation, you ask yourself, how far left does the graph go? How far right? How far left? -2. It's closed, so a bracket. How far right? To 4. Closed circle, so it's a bracket. And that would be your answer in interval notation. We're going to move on to the next example, and this is our last example. And this is an example of when the word or is used, okay? When two inequalities are connected by or, that means the solution set will consist of the values that are in both sets, okay? So once again, let's go ahead and solve. I'm going to solve both inequalities. divide by 6. P is less than or equal to -1. And then I'm going to go ahead and solve the second one. P is greater than or equal to 4. So now that we have our two inequalities, we're going to move on to step 2, which is graph the solution set to each inequality on its own number line. So I'm going to move this up, get my number lines going. Oh, that looks bad. Okay, so here is 0, and then I'm going to show -1, which is right here. It's less than or equal to, I can close it. So it says the values of P are less than or equal to -1. So we would go to the left to -infinity. Now I'm going to go to the next one. I'm going to identify my 0, and I'm going to identify my 4, and the values of P have to be greater than or equal to 4. So once again, the circle is closed, and then I'm going to go to the right. Okay, so if it's closed, then it can include those values. If it's open, it cannot. And then we are now going to go to our third step. Use the two number lines to graph the solution set of third, which consists of the total union of what would be shaded if you combine the two number lines together. So now I'm going to draw my third number line. Man, my lines are not straight. Okay. And then I'm going to identify 0. Okay. Now I'm going to draw the first number line. So here's -1. It's closed, and it goes on to -infinity. Then I'm going to draw my second one, which is at 4. It's closed, and it goes to +infinity. So all of the values that are included and combined in both. And now we're ready to go to our last step, is use the third number line to write the answer in interval notation. So the interval notation is going to look just slightly a little bit different for the OR. But you still ask yourself the same question or questions. How far left does that graph go? It goes on to -infinity. Remember, infinities always use parentheses, whether it's negative or positive. And it goes to -1. And it can include that set, so it's a bracket. And then there's a gap. So none of those values can be included. So we know there's going to be a union. And then we go to 4, and that 4 is closed, so bracket. And then how far right does that go to +infinity? And that's a parenthesis. And that would be your answer in interval notation.